Welcome to Aero Guide. In this video, we'll explore the aircraft propeller governor, a critical component in constant speed propeller systems that manages engine RPM automatically. Let's dive in. A propeller governor is an engine RPM sensing device combined with a high-pressure oil pump. It plays a key role in constant speed propeller systems by keeping the engine running at a set speed, even when flight conditions change. It works by adjusting the oil flow to a hydraulic piston connected to the propeller blades. This changes blade pitch, which in turn regulates engine load and speed. In a constant speed propeller system, the governor typically supplies oil to move the blades into a low-pitch position. However, a few non-feathering propeller designs may operate in the opposite direction. The blade angle is controlled by a combination of mechanical, aerodynamic, and hydraulic forces. Let's break down the key ones. Centrifugal twisting moment, a component of the centrifugal force acting on a rotating blade that tends at all times to move the blade into low pitch. Propeller governor oil on the propeller piston side balances the propeller blade flyweights, which moves the blades toward high pitch. Propeller blade flyweights always move the blades toward high pitch. Air pressure against the propeller piston pushes toward high pitch. Large springs push in the direction of high pitch and feather. Centrifugal twisting force moves the blades toward low pitch. Aerodynamic twisting force moves the blades toward high pitch. Not all of these forces are equal in strength. The governor oil pressure acting on the piston is the most powerful. This piston is mechanically linked to the blades, so as it moves, it rotates the blades accordingly. If the governor reduces or removes oil pressure, the opposing forces, like springs and centrifugal twisting, take over and move the blades in the opposite direction. The propeller governor used in constant speed systems is engine-driven and single-acting. It receives oil from the engine's lubricating system and boosts its pressure to the level required to operate the pitch-changing mechanism. The governor includes several key components. Gear pump boosts engine oil pressure. A pilot valve, controlled by rotating flyweights, that directs oil to or from the propeller piston. A relief valve system that regulates the operating oil pressure inside the governor. A speed-sensitive flyweight assembly that tells the pilot valve which way to move. A key part of this mechanism is the speeder spring, which resists the outward movement of the flyweights as they spin. The tension on this spring can be adjusted by the propeller control on the control quadrant. The tension of the speeder spring sets the maximum RPM of the engine in the governor mode. When RPM climbs to that set point, centrifugal force pushes the flyweights outward, overpowering the spring. The pilot valve shifts, oil is released from the propeller piston, blade pitch increases, and the added load slows the engine back toward the selected speed. Conversely, if RPM falls below the set value, the spring wins. The pilot valve meters high-pressure oil back into the piston, pitch decreases, and the engine accelerates. By constantly metering oil into or out of the propeller piston, the governor keeps the opposing forces in balance and holds the blades at the exact angle required for constant speed operation. The governor operates in three conditions: underspeed, overspeed, and onspeed. When the engine runs slower than the RPM set by the pilot through the propeller control, the governor enters an underspeed condition. In this situation, the centrifugal force on the flyweights is too weak to push them outward. As a result, the speeder spring pushes the pilot valve downward. This downward motion opens the governor's oil metering port, allowing high-pressure oil to flow into the propeller piston. As oil fills the piston chamber, the blades shift to a lower pitch angle, reducing aerodynamic resistance. This lightens the load on the engine, allowing it to speed up and return to the target RPM. This typically happens when nose of the aircraft is raised or the blades are moved to a higher blade angle. This increases the load on the engine and the propeller tries to slow down, but the governor senses this drop and responds by lowering blade pitch to maintain a steady RPM. When the engine RPM rises above the value set by the pilot, the governor enters an overspeed condition. In this state, the centrifugal force acting on the flyweights becomes greater than the opposing speeder spring force. This causes the flyweights to tilt outward, lifting the pilot valve. The upward movement of the pilot valve opens the governor's metering port, allowing oil to flow from the propeller piston. As oil leaves the piston chamber, the propeller blades shift to a higher pitch angle. This increase in pitch raises aerodynamic drag, which helps to slow down the engine RPM, returning it to the selected setting. This is how the governor responds to an overspeed condition, by adjusting blade pitch to stabilize engine speed. When the engine is operating at the RPM set by the pilot, the governor is said to be in an on-speed condition. In this balanced state, the centrifugal force from the flyweights is equal to the opposing force of the speeder spring. As a result, the pilot valve remains centered and no oil is directed to or from the propeller piston. Because the oil flow is neutral, the blade pitch stays constant, and the propeller maintains the selected RPM. However, if anything disturbs this balance, like a change in aircraft attitude or the pilot adjusting the propeller control, the system will shift into an underspeed or overspeed condition, and the governor will respond accordingly. Most propeller governors can maintain RPM within a range of about 200 RPM. Beyond that, they lose control accuracy. Some aircraft include overspeed governors, backup protection against excessive RPM, feathering systems for shutting down engines in flight, synchronizing units, match multiple engines prop speeds. To wrap up, the propeller governor is an automatic RPM controller. It adjusts blade pitch using oil pressure and flyweights. The system keeps RPM constant. Even when flight conditions change, it's a key part of constant speed propeller operation and engine efficiency. Thanks for watching.